what you have to know, and memorize and know how to use is just a couple of those quarks, as I mentioned to you before. So we'll go through the ones that you need to know. So when we think about subatomic particles, like our quarks and our leptons and things, they have fractional charges. So that means less than the elementary charge. Quarks, they cannot be isolated. Combination of quarks make up protons and neutrons. Now, when we have stable matter, it's composed of only up and down quarks, so no antimatter or antiparticles, because in your table of your standard model, each particle has an antiparticle. So like an up quark has an anti-up quark, and a down quark has an anti-down quark. So any antiparticle or antimatter, this refers to having the same, it's the exact same except one property is different. So there's only like one difference about them, and they're always represented with a line over top of the symbol. And the one that you guys have already done so far is, you did your neutrino, and then this was your antineutrino, right? So it was the antiparticle of the neutrino. And the way that we represented that it was the antineutrino was we put the line over top. So, and that's applicable for all antiparticle, is that it's just the same symbol with a line over top of it. So, for example, you need to know about your up quark and your down quark. So an anti-up quark is just the U with the line over top of it, and the anti-down quark is the D with the line over top of it. So everything is the same about them except the sign of the charge. So the charge is the same in both up quarks, but this one is positive and this one's negative. Okay? So when we think about a proton and a neutron, just as I said kind of at the beginning of the, don't kill him. Okay, at the beginning of the lesson, the proton has two up quarks, so I'm going to represent them with a U now since I know that that's its symbol, and it has one down quark. So now let's just kind of conceptualize what each charge is. So it's set up there that the up quark is positive 2/3, and then the down quark is negative 1/3. So let's add all of these charges that make up a proton and see what we get. So if I have a 2/3 plus 2/3 plus negative 1/3, okay, I'm going to get plus 1. Which makes sense because that's what a proton is. It's a charge of plus 1. So quarks help to explain why a particle has a certain charge, why protons and neutrons have charges. So then a neutron, let's do that one. It has one up and two downs. Now when you're writing the up quark, make sure it's a U and not a mu. Like it's a U, not a mu. Okay? You know what I'm saying? I don't know. When I'm writing the U's in science, sometimes I write a mu, so I'm just giving you a heads up. If you make that mistake too, I don't know. Okay, so this one is plus 2/3, and then I have two negative 1/3. So now let's add all of those together and see what we get. So we have 2/3 plus negative 1/3 plus another negative 1/3. This will give me 0. Which makes sense because a neutron has no charge. Okay? But it's made up of these charged quarks, but all together they will give you a neutral charge. now I'll just show you, this is the last outcome in your lesson, so we'll go through negative beta decay and positive beta decay. So negative beta decay, let's just represent it with like the most simple representation of it. So we start with a neutron. It decays into a proton, and since it's beta negative, a beta negative particle, and I also get an antineutrino. Now, if I was to kind of take this information, and now that I know that a neutron is made up of, neutrons and protons are made up of quarks, I'm going to replace what I have here with kind of the variables of a quark. So a neutron, its quarks are up, down, down. A proton is up, up, down. And the beta negative I'm going to represent as an electron, a negative. So I'm going to write it E negative. And my antineutrino stays the same. Because what I did here was that I replaced like this equation with symbols from the standard model, right? Each one of these is a symbol in your standard model, right? Like that you have the electron in your standard model, you have the neutrino in your standard model. So it's all representations from the standard model. Now here, this is one additional information. An electron and an antineutrino together make up a negative W boson. Okay? All right, and then, so let's do the same kind of thing for positive beta decay. So we start with beta positive, we start with a proton. It breaks down into a neutron, a beta particle that's positive, and a neutrino. Oops, not with the line over top. So now let's go and replace each symbol with a symbol that we find in the standard model. So our proton is up, up, down. Our neutron is up, down, down. We can have our E plus because it's basically it's like an antiparticle of the electron. And we can keep our neutrino as is. So this positron, right, because this is called a positron, okay, positron, and a neutrino make up a W plus boson.